Alright, so we're going to work through solving this this differential equation where we have initial values given to us as x of 0, which is, just say x of t when t equals 0 is 0, and also that x prime of 0, so the derivative of x, is also equal to 0. And I'm going to work through solving this in two ways. So the first way that I'm going to show this is maybe intuitive guessing, this is kind of the method that's always shown on other videos and other methods that you'll see online, and it's totally bullshit because no one is born knowing how to understanding how to solve this kind of intuitively. The only way you get intuition is by doing what I'll show in method 2, which is actually guessing. Because the intuitive guessing is basically, the way you do that is you say, oh, we're going to assume that this is the solution, and I'm going to show you that that is the case, and you're kind of left being like, where did this come from? So actually guessing, which is the way that when you're in a differential equations class, this is what you actually do as a student. But I'll start with number 1. So So we're going to look at this equation. I'm going to rewrite it. I'm going to write it using the prime notation for ease of notation. So the second derivative of x with respect to t plus omega squared times x equals f naught cosine of omega t. And I'm going to write this just as equation 1 because I'll be referring to it a lot. Okay, so our job is to first solve this equation, and the way that we solve this is we're going to have, basically you need to break this into two different equations. You need to say, well, you need to solve, the equation itself, so find x as a function of t such that this holds cosine omega t. So I'll write this as maybe 1b, but first, or at least the way I would solve it first, is you need to solve what's called the homogeneous equation, where the left-hand side is equal to 0. And the reason you do that is because you need to have both 1a and 1b combine. So you have x is going to be basically your answer for 1a and your answer for 1b, because this is just going to be equal to 0 because we set that at 0. So it doesn't change anything by adding it, and this is what's called the particular solution, where it is equal to f naught cosine omega t. Technically, like this, just 1b would be correct, but it wouldn't be the most general solution you can have, so you also need to include the part for 1a. So I'm going to erase that part, and I'll start by solving 1a and say, okay, we know what this looks like. This looks like simple harmonic motion, because it's the second derivative plus the function itself. And generally this is going to be some form of sines and cosines. So I'm going to switch here, and again, it's like, how do I know that? It's because I've done a lot of these problems. That's how I know that. So I'm going to guess for 1a that x is going to equal some constant c1 times sine omega t plus some constant c2 times cosine of omega t. Alright, and if that were the case, then we're going to calculate, I guess, derivatives and plug in. So this is going to be then x prime would be, let's see, derivative of sine is going to be cosine omega t, and we're going to gain an omega out front. And derivative of cosine is going to be minus sine, and we're going to get an omega out front as well. Okay, and then x double prime, the second derivative, is going to be equal, we're going to get another factor of omega, so it'll be omega squared c1. Derivative of cosine is going to be minus sine omega t. and derivative of sine is just going to be cosine, and we get another omega out front. So we get omega squared, and this is going to be cosine of omega t. Alright, and now we're going to switch colors, plug in to, so x squared, the second derivative plus omega squared x equals 0. So x, the second derivative of x is going to be here, which is going to be minus omega squared c1 sine omega t minus omega squared c2 cosine of omega t. Okay, and then x is going to be right here. Okay, and we're going to do plus omega squared times x, which is going to be c1 sine, just reading off from the blue, plus c2 cosine of omega t. Okay, and this should equal 0, and let's see, this is going to be, I'm just going to rewrite this as going to be minus omega squared c1 sine omega t minus omega squared c2 cosine omega t plus w squared, I'm going to distribute the w, c1 sine of omega t plus c2 omega squared cosine of omega t equals to 0. And let's see, we have minus omega squared c1 sine here, and a plus omega squared sine 1 c1 sine omega 2 as omega t here, so these are going to cancel, and similarly these are going to cancel, and okay, the hand side is 0. Okay, so this is actually going to work for our solution for 1a. I'm just going to rewrite it. So we have x equals c1 sine of omega t minus c2 times times c2 cosine of omega t. I'm going to box that. Okay, let's see if we can get a nicer box. Software doesn't always recognize when it's slanted. Great. Okay, and now let's go ahead and get 1b. So 1b, now we're going to try and solve for second derivative of x plus omega squared x equals f naught cosine of omega t. Okay, well, I am going to take one, bad guess here, and well, I mean, we can see from 1a, if we were to have x equals, say, for example, sine omega t, say f naught sine omega t plus f naught cosine omega t, we know, so if we were to guess this, we know from what we did in 1a that that we would have x double prime plus omega squared x equals 0. We know that because that's what we calculated. This is exactly what we have here, except with f naught as both of our constants. So really what we need is we need something to generate, the question we're trying to answer is what would generate this. So we're going to take the derivative twice, and we're going to generate f naught cosine omega t. And the only way that you're really going to be able to answer this is if you've done, a handful of these problems. And in particular, you might have noticed that if you have something of the form, for example, let's say x equals t times e to the t, well, the first derivative of that would be, we're going to use the product rule here. So this is going to be the derivative of t, which is just going to be 1, so 1 times e to the t, plus t times the derivative of e to the t, which is just e to the t. So this is going to be e to the t plus t e to the t is going to equal x prime. And similarly, if we took the second derivative, this would be again, with the product rule, well, first we're going to, it's a linear operator, so we can distribute, but we're going to have here is going to be, let me write it a little bit more formally, the derivative with respect to t of e to the power of t plus t e to the t is going to be equal to d, the derivative with respect to t. With respect to t, my pen is misbehaving. E to the t, we can distribute the operator d divided by dt of t e to the t, and this is just going to be e to the power of t, and this we know from taking the derivative the first time is going to be e to the power of t plus t e to the power of t, which is going to be equal to 2 e to the power of t plus t e to the power of t, which is going to be x double prime. And you can notice that this, because x is here, x is t e to the power of t, we're going to have x double prime is going to equal 2 e to the power of t plus x, basically. So we can say that this function is going to generate, one set of e to the power of t for every derivative that's made. So with that kind of in mind, we can go ahead then and make a different guess, which is to say, okay, with this kind of motivation, why don't we guess that x is going to equal, well, we want cosine, so why don't I guess that x is going to equal some constant, just write C3 because we have C1 and C2 down here. So it's going to be some constant times t times cosine omega t. Okay, then we're going to enumerate it. 1 is going to be guess, 2 is going to be calculate as many derivatives as we need. So this is going to be different color. X prime is going to be a little bit more of a pain to take these derivatives, but it's going to be writing this out explicitly as product rule kind of notation, is going to be the derivative of t, which is just going to be 1, so it's going to be c3 times our second function, which is cosine omega t, plus the derivative, plus I can write c3 times t, times the derivative of cosine of omega t, which is going to be, I have to rewrite the first term, cosine omega t, plus the derivative of cosine is going to be minus sine omega t times an extra factor of omega, so it's going to be minus c3t omega sine omega t. Okay, and I'm going to rewrite this here, so x prime is going to be c3 cosine of omega t plus, or rather minus c3 times t times omega times sine of omega t. Alright, and then let's take the derivative again. Switch colors here. We're going to have x double prime is going to be, well, the derivative of this is just going to be minus omega c3 sine of omega t. Alright, and the derivative of this, again, we have to use the product rule, so if we take the derivative of just t, that's just going to be 1. So we're going to have minus c3t, sorry, the t is gone, it's just a 1, so c3 times omega sine of omega t. I saw that, I see that my software auto-corrected this to be a circle, sorry about that, t. You can ignore this circle. It's just a pain to erase. And then back here, now we have to take the derivative of this second term again, but now we're going to take it with respect to sine, and that's going to be, the derivative of sine is just cosine, so we have minus c3t, another factor of omega, so it's omega squared, cosine of omega t. Okay, and we can see that we can combine these two. So combine. And so we get the second derivative is going to be minus 2c3 times omega times sine of omega 2, times omega t, minus omega squared times t times c3 times cosine of omega t. Alright, and now we'll do our third step, which is going to be 3, which is going to be plug into 1b. And so again, 1b is going to be, where is 1b? Right here. Right here. It's x double prime plus omega squared x equals f naught cosine of omega t. And let's see, this I'm going to copy from here, and I'm going to change colors. It's going to be minus 2c3 omega sine of omega 2 minus omega squared t times our constant times cosine of omega t. And this omega squared x term is going to be from here. And we're going to have, so we're going to have plus omega squared times x, where x is going to be c3t cosine of omega t. And that should equal, if this is the correct guess, f naught cosine of omega t. And let's see, well, this is going to be here. We have minus t c3 cosine omega t. Here we have plus omega squared c3t cosine omega t. So these are going to be 0, cancel. And we are left with minus 2 c3 times omega times sine omega t equals f naught cosine omega t. Okay, so I'm going to shift down a little bit. So we actually have a problem because sine of omega t is not equal. There's no value for c3 that we can choose that is going to have sine of omega t equal cosine omega t. And what this means is that we need to go back and adjust our guess. Need to adjust guess, because basically what we see is that our adjust guess, we're off here by a phase. So we need to adjust our guess by a phase. But what I mean by that, let's see, I need to think if that's a phase or two phases. But basically, we're going to re-guess so basically the logic is started with cosine, ended with sine, but we need cosine, so we're going to start with sine. So we learned that when we take the derivatives twice, we're going to shift by a phase. So what we need to do is calibrate so that we shift by phase in the right direction. So let's do this quickly, and we'll go ahead and guess x is equal to c3 times t times sine omega t. Okay, then 1 is going to guess, 2 is going to be calculate derivatives, and that is going to be the derivative of x with respect to t is going to be, well, the derivative of this, and we're going to do the t first, is going to be c3 sine of omega t, and the derivative, again, this is from the product rule of sine, is going to be cosine, so we're going to have plus c3 times t times omega times cosine of omega t. Okay, and now let's calculate the second derivative. I'll just keep it as green. So the second derivative is going to be the derivative of this, which is going to be C3 omega cosine of omega t plus the derivative of this, which is going to be using the product rule t first, is going to be C3 times omega cosine of omega t. And then we have to do it again because of the product rules. Derivative of cosine is minus sine. We're going to have C3 omega squared times t times sine of omega t. I'm taking these derivatives kind of fast here, but if this were on exam or something, write it out a little bit more so you don't get turned around. All right, and now we have enough that we can plug in to our original equation. So plug into 1b. And now I feel that we're on the right track because we see we have some cosines here. So let's see. So we're going to go, and so again, 1b is our equation here. So this is going to be right here, and we're going to have, let's see, C3 omega cosine of omega t plus C3 omega cosine of omega t, and then minus C3 omega squared t sine of omega t. And then we're going to have this term, the omega squared x, which is going to be from just our guess, which is going to be plus omega squared C3 t sine of omega t. And this should equal, move the board a little bit, this should equal f naught cosine of omega t. Alright, so let's look. Well, this is going to be minus C3 omega squared t sine of omega t, and that's what we have right here too. So these terms cancel, and what we're left with is going to be, these are the same terms, so this is going to be combined. We have 2C3 omega cosine of omega t equals f naught cosine of omega t. And this is great because we can see that if we let, we can have this equation be true if we, let's cross out the cosines, and if we have C3 equal to f naught divided by 2 omega, then this equation will be true. So we found a constant which would have our guess work, so that means that we can then just write this as if we have x equal to f naught divided by 2 omega times t sine of omega t, this is going to work for our particular solution to this initial value problem. Alright, so this is 1b. This is going to satisfy 1b. So now all we have to do is combine them. So let me zoom out here. Alright, and so I'm going to rewrite down here. So our last step is going to be, now we're ready to finally to solve this problem, solve the initial value problem. And we know that x is going to be the general solution to x plus the particular solution to x, which is going to be, in this notation, the x from 1a plus the x from 1b, which is going to be, the x from 1a is right here, which is going to be c1 sine omega t minus c2 cosine of omega t. And then the part from 1b is right here. We're going to have plus, f naught divided by 2 omega times t sine of omega t. Alright, and we just need to solve it with the condition that x of 0 equals 0 and x prime of 0 also equals to 0. Alright, and so what this means is, let's solve, here I'm going to write equals x, okay, and we're going to have x, and I just like to write explicitly when t equals 0 equals 0, so that means we need to set t equals 0 and x equals 0. So let's do that. So we're going to rewrite this equation with x equals to 0. So we're going to 0 equals c1 times sine of omega times 0 minus c2 cosine of omega times 0 plus f naught divided by 2 omega times times 0 times sine of omega times 0. And this is going to be 0, since sine of 0 is 0. This is going to be minus c2, since cosine of 0 is 1. And this is going to be 0. So what we're left with is 0 equals minus c2, and that conveniently tells us that c2 has to equal 0. Okay, and then we just have one step left, and then we're done, and we can write x prime of t equals to 0 equals to 0. So first we need to rewrite x using, so we can use this information to make our life a little bit easier, using c2 equals 0. So we're going to have x then is going to equal sine c1 sine of omega t plus f naught over omega 2 omega times t sine omega t. Alright. And then we have the derivative, so x prime is going to be, so we need to just take this derivative again, so derivative of sine is going to be cosine, and we pick up the omega, so omega cosine of omega t. And the derivative here, we're going to use the product rule, so the derivative of just t with respect to t is just going to be 1. So we have this, and the derivative of sine of t with respect to t is going to be cosine t, so we get plus f naught over 2 omega times t, pick up a factor of omega times cosine of omega t. Okay, and now we need to plug in for x prime of t equals to 0 equals to 0. So that means that we need to set t equal to 0 and x prime equal to 0. So let's do that. So x prime equals to 0. I'll switch colors here. So we have x prime equals to 0, which is going to equal c1 omega cosine of, I'm just going to omit the omega in here and just write 0 because omega times 0 is 0, plus f naught over 2 omega sine of omega t, which is just 0, and plus f naught over 2 omega times 0 times omega cosine of 0. And this is going to be 0, this is going to be 0, and what you're left with then is that 0 equals cosine of 0 equals 1, so this is going to be c1 omega equals 0. And assuming that omega is not 0, which it could be, but then you'd have a trivial solution, you'd have c1 equals 0 as well. And what this tells you then is that your final solution to this, kind of frustratingly, because we wasted some time, is that c1 equals 0, c2 equals 0, and that means then that your solution is just x equals f naught over 2 omega times t times sine of omega t, and that is your final solution. again, this was solved using kind of some intuition based off what we should guess. Basically, the intuition here is that that we used is when you have a simple harmonic motion, your form is going to be something like a sine and cosine term. And then beyond that is we kind of had this insight of when you have a cosine term or some term that's not zero, it needs to be generated some way. It needs to be generated from your derivatives, and the way you can generate from derivatives is when you have an exponential times something. So that's how you can solve this problem using kind of, once you have enough intuition to see where that's to go. I'll now take a second to talk about how you might actually guess this if you kind of don't really have these sorts of insights.